Well, let me know if the sound's good. Apparently Streamlabs changed its interface a little bit. That's good. Apparently Streamlabs is not showing me the correct number of people today, so I don't know how many people are in the chat unless you sound off, because it's showing up as 0. It might be some kind of error in Streamlabs, so. But let me check the camera, see if it's functioning. Kind of. Let me see if I get Streamlabs working here. Yeah, it's hard for me to tell how many people are in the chat. Normally it shows in the bottom in the chat app, but today apparently it's different. Let me see if I can download the embedded. That's better. It works in the other one. Awesome. So apparently the dashboard for Streamlabs doesn't work too well on the internet, but let me move this over. So today I thought I'd talk about boards. I want to clear up confusion as to what to do and when to do it. So I've got two boards. They're similar in lineage, but different. So we've got the Octopus here. We have the Octopus Pro. We have the SKR version 1.4, and you can't really tell what the difference is from the top. There is a sticker on the back that tells the difference, but the labeling on these is obvious. So I'm going to move these over for a second, and I'm going to show you my trick for doing this. So one of the issues that you'll run into is, what are you working with for your processor? So all you have to do is zoom in with a magnifying glass. And this one might be a terrible example, but you can see right there, well, let me put my hand close to it. It says LPC 1768. So this is a regular SKR 1.4. It's not the turbo. So let me bring in the other one. So this one, if I move my hand so you can see it, hopefully. There we go. It says LPC 1769. So that tells you which processor you're going to be working with for that type of processor. Same is true for the other two boards, which I'll show you. So here is the Octopus. It's upside down, but it says STM32-446. I think it might be the same for the other one, but we'll find out. So this one says STM32F446. So it is the same for this one. It's just different wiring for the board. Now what I'm going to do is zoom out, and I'm going to see if I can find a different board that actually makes more sense. There's one where they changed the processor because they ran out due to production issues, and I think I have one someplace. It's the SKR version 2. Whoop, almost dropped my basket of boards. So I'm trying to find a good example. Here's a BTT002. This one might be slightly different. Let me see if I can zoom in a little bit more. So this one says STM32F407. So it's written right in here. But there's one for the SKR3, or excuse me, SKR2 that I'm trying to find. But apparently I can't find it. So let me sort through these boards real quick here. It might be on my desk right in front of me and I just don't know it. But I do have a different board for the GTR, and I actually see the board now. So this is the GTR. You can see that it's 407 again. So there's a pattern forming is what I'm trying to do. Here's the MKS Gen L, or excuse me, Gen L. This one's going to be very different. Let me see if I can adjust. There we go. It says ATmega 2560, which means that it's an 8-bit processor. And I'll zoom out so you can see the board. And essentially, this is set up with the wiring for TMC stepper drivers, but still an 8-bit board. So what they've done is they've changed the tracings so that you now can use those steppers for the TMC. But let me see if I've got the board that I've been looking for the entire time. So there's one. I think I got two of these on hand. Not sure what the processors are, but it's the exact same board with some minor differences. So this one says STM32F407, and this one says STM32F429, I believe. So as you can see, that's going to dictate what you load in the actual firmware. So I'll zoom out again, and I'll put this board down, and essentially I'll show you what's going on in VS Code. So if we transition over to VS Code, as soon as it comes up, give me a second to get to it, you can see that I have, no build loaded. So I'm going to open a build, and I'll go to downloads. I've already extracted this, so I have to go 2 Marlin folders deep and select the folder. And I'll check on the chat because I know I've been talking for a little bit of time here. Basket down. Yeah, the basket was down for a second. So essentially inside of here, what you can see is that I'm actually working with the default Mega 2560 initially. Now you guys have seen me change this 1,000 times. So essentially what we want to do is examine some different stuff. So a lot of issues that will occur with your boards have to do with pins files and understanding how they work. So one of the tricks that I use is I can go over to, for instance, Marlin. This won't give me much information, but it might tell me what the actual bugs are. So if we go over and we look at downloads, we can actually cheat and go to release notes and see if there's anything in here that has to do with the build that has changed. Or we can go over to reporting an issue and search on it. And of course, if you search on TMC 2209, usually there's an issue. So as you can see, there's like a retraction problem and other issues that might occur that are related in here. Now, some of these won't say bug initially because they've just recently been reported. So they usually put bug in once they've identified it. The other thing that I like to do is I like to go over here to understand what's occurring. So for the SKR2, it's not on the front page, so you have to go to Find Repository SKR2 or -2 and then pull it up. And of course, they're going to talk about what issues they might have and the differences between chipsets. That's one of the things I just showed you so you could identify it. But also they have a manual in here someplace. I think it's under hardware. And then we have the manual. Now the manual is really useful for setting up things that are common, but you might do something that's different that might require some other configuration. So what you can do is I usually use the pins file to identify where things are. And these tell me what the pins are, and they correlate to VS Code. So if we go over here and we go to Marlin, Source, and then we go to Pins. Inside here we have it broken out by chipset. The number that I was reading off, the STM32F. So in this case, this is going to be the F4 that we're going to go into. And as you can see, there's several versions of boards in here. For instance, you have the SKR Pro version 1.1, and then you have the Pro 1.2. If you open one of these, you'll see that it says include pins _BTT _SKR _Pro _comment. That means it's including this file at the end of this one using the actual C technique of saying tack on or append this file to what I'm working with. So technically these two things, being the Pro and this, are one thing when it's compiled. So inside here you can see that it's probably got some more includes. Then it's got the pins. These are the gold of your board. This tells you what goes to what. So you can see that it says PB10 and then it says X minus. So that means X minimum. So in this case, in this case it's saying it's defining or it's making a variable for that particular pin on this board. So I'll show you what that looks like. So if we go over here to the X minimum, you can see, let me make sure I got the right board. I don't. So let me go over to the one that's the right board, because I'm talking about the SKR Pro when I'm actually looking at the SKR2. So we'll find the SKR2 in here and then match them up. So it's going to be BTT SKR Rev 2, or excuse me, 2 Rev B. That's the only one you can use. This one is defective. And so it's going to say go to common. So we'll go to common, and inside here we've got our pins. So in this case they only talk about 5 pins, which is odd, but maybe there's a reason for that. And then they have other pins. So you see it says PC1 for the X minimum right here. So to find that, we can click over here, and as you can see, you have your X minimum, and then over here it talks about what the pin is. So it says PC1. So if we flip back, you can see that it says PC1, and that correlates to that. Same thing goes for X minimum, which is PC3, and that works. And then finally PC0, which is here. And then it says PC2 for the X max. So PC2. And then we have PA0. And these are for the end stop, or excuse me, for the filament detects. So it's going to correlate right here for your signal pin. The other two have to do with voltage, so it's plus 5 volts and ground. So ground's always going to be in the center, voltage is always going to be on top. Now that we understand that, there is one that we don't know what's going on. It says PC15. So the trick you can do is you can go in here, hit Control F, do a search on PC15, and you can see that down here it says that it's the X max. So this is a stall sensitivity. Then it's used for, let's see, Z multi end stops. So it can be used for X and, or excuse me, for 2 end stops on the Z axis, possibly. I've never set that up, so hopefully I'll build the printer that'll be able to show you that, or at least an access. Let's see. There's other things here that have to do with your steppers, and I'll show you something interesting about this. The X underscore CS underscore pin, that means the X axis, and CS stands for chip select, and then it says pin. The only time this will be used is when you're using sensorless homing. So if you wanted to create other pins from this, because this goes to PE0, which we know over here corresponds, hopefully, well, I'm not correct there. It's going to be a chip select someplace on the board. So here it is right here, and that's for the end stop in here. So one of these pins corresponds to that, and they do that for each one of these. So they're laid out in a way. These are all signal pins, and they're digital pins, not analog. The analog pins, though, may be right down in, I'm trying to find the actual analog pins. I think it's around in here. Here we go. So PA1, that's an analog pin. PA2 is an analog pin. And PA3, this is for the thermistor. So the way they read it is with analog signal. And essentially with the thermistor, it's a piece of glass, and there's a known rate at which the flow or signal of electrons will occur. And in that case, you can tell the temperature based on the sensor that you have of what temperature it is detecting based on the flow of pulses through it in analog. So Now that we know all these weird things about the board, there are other pins that are around the board that'll give you more detail. Some of these have to do with power control. For instance, your heaters. So you can see that there's a PB4, a PB3, and then you have your fans, which is PB5 and PB6. You can digitally control the actual temperature with these, and with these you can actually run or control the fan speed. Now the other setting, VBB, I believe that's voltage, but I don't know what the BB stands for. But you can see that it's the positive pin on the actual diagram right here. So they give you hints as to positive and negative. And then over in here, they tell you that it's, well, 5 volts is a positive signal, and ground is going to be your negative in this case. And they do that throughout the board. They do something weird down here. Instead of saying VBB, they say what voltages can go in and out. So you can see there's a DC in, which means direct current, and what that can be is either 12 or 24 volts. So that gives away a lot about this board. Obviously, they don't say much about the processor, but if you want to know more about the processor, there should be a data sheet in here someplace. Not sure where they put it, but the data sheet is a good way to understand what's occurring. And apparently they don't include it in here like they do with other boards. So let's see if I can find one real quick. Maybe it'll be in the SKR. If we go in here, go to hardware. Let's see, manual. I thought they had a data sheet in here at one point. This is going to be the manual for the whole board, I'm guessing. So let's see if I can find the folder for this. It's probably called Datasheet, or Master of the Obvious here. So this is the actual processor on the board. You can actually look these up on different websites. In this case, it's talking about I2C. That might be a function of the board, or it might be the manufacturer in this case. But you can see that it's a 32-bit processor, explains about it, can tell you a lot about your chip. I'm trying to find something interesting to show you real quick. It says the different variations of the board. It says what the clock speed is right here. And then of course, it might vary between the other boards. It's 100 megahertz up here. Let me see if I can find something in this data sheet that's interesting. I'm trying to find the pins. And it might be kind of confusing for me to show you. Okay, let's see if this corresponds to something. So let me duplicate this. Go back over here. Inside here, we'll go to hardware, pins, and then we'll see if anything corresponds. Notice how they have it different here. So in this case, it would be P for the pin, 2_1. And I'll show you why that is. They do it differently for notation per board. So if we were to go over to the folder for the LPC 1769, and then find the Big Tree Tech 1.4 or 1.3, they might point to a common lineage. You can see that the notation is slightly different. So by using this right over here, we might be able to decipher what pin is what. So I'm trying to find something that's common. And it's kind of hard to do because it's set out around the corners of the chip. So this might be a mess for me to show you. But essentially, what's occurring up here is each one of these things traces to a pin on here. And so each one of these pins is like a mailbox. So essentially, what's occurring in here is this is a database of functionality that's mapped to the chip that then is mapped to the Marlin firmware. So no matter what you're working with, you'll have an outline here if the board exists, or you can create one, which then will correspond to the board tracings and the functionality you're working with. Now there are functionality in Marlin where you can turn on and off pins. It sometimes doesn't work because they have a protected pin. But let me check on the chat because I know I've been talking a little bit long on this. Yeah, I2C is IIC, which is a protocol for passing signals back and forth. It's similar or different to SPI, which is serial peripheral interface. And each one has a chip to control the actual communications. So, let me double check something here because I know Restream is so much fun. Okay, already checked that. So, essentially, now we understand how the pins map to the board, and we know how they map to Marlin. There's some other things that I can point out that make it simpler. So if you go over to Configuration Advanced, one of the good things that you can see is that down in here, sometimes they'll say -1 for a pin. Gotta see if I can find an example real quick. Of course it's buried, there it is. So if you want to work with a fan, what they do is when they put -1, they mean the value is not in use, and you can specify it to your pinouts that you find in your data sheet or in the pinout diagram that's usually on like the SKR, which I have to go over here to show you. So these correspond to functionality you might use. So if you want to use a fan, you might be able to use this or this, but depending upon the actual software that you're working with for Marlin, they may protect a pin and shift that functionality someplace else. So on this particular board, it's limited, but if you go to other boards, there's more functionality. So if I go back over to Big Tree Tech for a second and I go back to the board for the SKR2, you'll see the difference. So the SKR2 has more available control pins for fans. So if you go into hardware, then you go to pins, you can see here they have the heater pins, which is hot end, then they have fan pins, and you have the actual signal pins. So you can use these, and then I think there's 2 more on the board. This one is actually just power, so you can see that it's voltage and ground. Same thing with this one. So these look like the only 2 controlled fans that you can control with pins. Now you can add control, but you're going to need a middleware of some type, possibly a fan controller that you're going to have to jumper in to do that. Or you could design a board to do it for you. But that's a little bit past the scope of what I'm trying to show you. But essentially you can create a board that is similar to a fan controller board and do the same thing and tie it to pins that are unused and then point to them. So now that I've covered all this, what I want to do is I want to show you excuse me, config files. So if I go over to, let me pull up the right site here. So over in here, we've already downloaded. I've extracted it. And what I'm trying to show you is that you can do some special functionality with the actual config files. but they're located right here. It says configurations. This is per build. So I'm going to click on this. Now, if you want to download it, you can just click code and then download zip. Once this is pulled down, we'll go over to the downloads folder and extract it. And a lot of people have different boards. And what I want to show you is the difference between the actual configurations. So if you right click here and then you say extract all, you can extract it real quick. This might take a second. But we can set up a third file and we'll call this compare. And I already have what's known as sGen. It's a little tool I use to compare with. It's also used for tracking or keeping track of code. But in this case, I'm just going to use it for something else. So inside here we have a config, then we have an examples folder. All the model printers that they know of have configurations in here, but some of the most common would be the Creality. And inside here you see all the different models. So I'm going to pick the Ender 3 Pro. Then you can see that it's done by board. So they do have the SKR Turbo. And then they have other boards. You can obviously make your own of this. But the trick to this is all you have to do is copy these two things. And you can pick out your own configuration as soon as I get to the folder. So we're going to go to compare. I'm going to paste it here. And I'm going to rename each one of these to example. And this is how you can figure out what your configuration may be. Also, don't trust these files because they can be in error. So I'm not a big fan of these, but a lot of people ask me about them, so I want to show you a good way to do this. And this will at least give you an idea or roadmap of what to do. So now that we have those, we'll go back over to here for the regular Marlin, and these are the unchanged files. I'll copy both, and then I'll paste them into the compare folder. And then with sGen, you can highlight one, hold the control button, highlight the second, right click, and then you can go and look for sGen right here and do a diff. And as you can see, the age of one file is different from the age of another. This is why they're usually out of date, not a sync. And then of course the example file is probably on the right. The brand new one's probably on the left, which is kind of funny because that's a minor issue that they should fix. It's actually 2022, right? So as you go down through here, anything highlighted in yellow is different. So as you scroll through here, you can find the configuration and what they're talking about and pick each one of these things out and take notes on it, because you might have a custom boot screen or may not. In this case, it's commented out with the little hash marks here or forward slashes. And then it's got the board type. In this case, this is the default board type, whereas this is the one that you're changing to. And so you can see all the differences. This is actually defaulted to an 8-bit processor, whereas this one's defaulted to a 32-bit processor. And that's the other thing I was talking about for using the first serial port to communicate with your board. The second one they already have set up. This one is actually used for the display. So this is the pattern I always use. They reverse it on Big Tree Tech's website, whereas I do not. And then as you go down through here, you can see that there's going to be different things. They might even have the configuration for your thermistors. Let's see, thermal settings. Inside here, they might tell you what they are. So they're using a default of 1, but these can vary. So as you can see, they're picking this one. I normally use this one, which, I mean, they're essentially the same, but there's actually a profile for each one of these and how they react. So if you actually use the one that you're using, these would be particularly important. I just picked this one because that's the one I used to use all the time, but it's probably this one they're using. And the same thing goes for your heat bed. So you can see that they give you all these choices right here for your different types of sensors. You can do, looks like 8 sensors for hot ends, and then you can do 1 bed. I don't know what probe 0 is. Then you have a chamber setting, a cooling sensor, which I don't know what that is, and then it looks like you can monitor the temperature of your board now. And then I don't know what this sensor is, but it says redundant, so it's probably a backup. If you're working with something where you want to create some kind of mechanical tool where you're not using actual temperature sensors, they give you default values that you can put in. So these are dummy values. I don't know how well they work these days, but you can substitute those in for the numbers up here, and then it won't trip up the actual compile because it'll be saying you're doing something else. And the reason that I tell you about that has to do with the new functionality they added up here. And there's a lot of new functionality. So up here they have linear axes. This doesn't work very well, just so people know. A couple of people I've tried to work with, or they've tried to explain to me how to set it up. But you can set up a mechanical arm in theory. But the problem is that this is rather not well defined in Marlin at the moment. So if you do uncomment this, you're going to have to troubleshoot all the issues that go with it. Now there is a mechanical arm someplace where they talk about this, that you can Google linear axes and they can explain this. But it gets very complex very quick, and so that involves a pins file and changing names and stuff like that. So that's kind of advanced stuff. Then of course you've got different types of nozzles. So you can see that there's a single nozzle. If you were to add more extruders, like up to 8, and it used only one nozzle, you'd remove the actual comment for this. Normally it's done for 2 for extruders. So that makes things simpler to configure. Now there are other types of nozzles that involve mixing, and that involves setting up scripts. So if I were to go down and find it, I don't know if they took it out or moved it. Used to be around there. Let's see. They may have moved it on me, but there was a mixing setting that you could do. Here it is. Mixing extruder. This is a whole subject matter within itself. Usually I just control it by what I put into the model and then slice it in. But there are ways to actually mix where you can use different types of slicers and mix in the colors. Essentially you're creating a pressure between each of your extrusions to mix the color into a color you can work with. Now there's several people in the Discord chat that know how to work with it. I am not one of them, but there's at least 2 people, maybe 3. So if you go into the chat and just announce it, one of them may answer. Let's see. Thermal settings I've already talked about. PID settings, this is usually used for tuning the actual heat that occurs, and there's an algorithm you can run that will tune the actual heating and cooling of your extruder. I've used it before, I kind of like it, but after years of not using it, I don't see a point for it, but it exists. It may make your prints better, or it may just not change anything. Normally I do everything now via slicer, and then I don't worry about this. But there's a whole thing on how to do this. Basically, they tell you to find a G code, and then you run that G code, and then you tune it. I don't remember what the G code is off the top of my head. And of course, there's chambers and stuff. They're basically PID tuning those as well. And then, as you can see down here, today we came across something where we're going to work with this. And this has to do with minimum temperatures. So if your extruder's not working, this is enabled by default, meaning that it will not extrude until you reach this minimum temperature in Celsius. Obviously, it's different between these two, but essentially PLA melts at about 180 degrees Celsius. 170 it may melt, but not likely. And then they also have ways to prevent the actual over extrusion. Normally it's 200. In this case, it's set to 450, which is excessive because this might cause jamming. But you can just test extrude, usually up to, I do about 100, maybe 75, just to make sure the extruder is working. But you're burning material with nothing when you do that. Let's see, they have more settings. There is thermal runaway. Do not disable these ever. This will prevent, if it gets too hot or can't tell the temperature, to turn off the printer with an error. Usually it's something due, it's a vague error. I can't remember if it's 66 or 99, but it's a code that pops. It usually means your thermistor broke. That's why you leave these enabled. Then you have different types of machines that you can work with here, meaning the axes and where they're located. Down in here they talk about homing. So you have your end stop settings, and essentially these are always defaulted on. You can change them, and as you can see, they have end stops for that thing I was talking about with the mechanical arm. This is more of that. As you can see, it's kind of confusing. It doesn't go A, B, C like it was saying up there. Then, of course, you have the inverting of your actual end stop signal. That has to do with if it says true or triggered, and it should say false, you can reverse it by inverting the true to a false or the false to a true. So it's not really that interesting except if your logic is backwards. One of the times you might use this is for detecting if your filament is run out, but that will be on the advanced configuration page. And then of course you can see that the configuration that they use for the example config on the SKR is actually using the TMC 2209, not the default configuration. So these are some of the weird things that they're going to show you in here. Then there's different things about movement. This would be your default settings to start with on the actual Creality Pro or Ender 3. Then of course they changed the actual default feed rates. That was a big question this week of why is my printer not acting right. This might have to do with print quality. So emulating the rates to start might be a good idea. I usually start on the left hand side and then modify upwards. But as you can see, there's different settings for different printers. So that's all has to do with speed. Now when they say jerk, let's see where that's written. Jerk is the acceleration speed and deceleration speed. I think they may have taken it out, but it's called the jerk rate. So it's how fast it accelerates and decelerates. I may have scrolled by it. Here it is. So that's something that I don't recommend playing with unless you don't mind buying more equipment. Down here we have the probe settings. As you can see, currently they're enabling a probe in here, whereas it's normally defaulted off. And then here they're doing, this is the default on the left, this is the change on the right. So we're probably going to see another change down below. So if we scroll down, you can see they enabled the BL Touch. So there's your configuration for the BL Touch they're talking about, and part of it's being modified here. Now there may be other settings if you're setting up a BL Touch. Notice how they have a nozzle offset, so they're assuming that your BL Touch is going to be in relation to that someplace. Then of course the probing margins are different. So as you can see, this is a great tool to figure out what your configuration should be if you're curious about a particular configuration. Down here they have inverting direction. So in the default Marlin, the one I prefer, if your actual axis is going the wrong way, not towards the end stop, you can invert the direction by changing the true to a false. And the same goes for your extruders. Bed size obviously is different from the default, which is 200. So it's 235 in the Pro. And then of course it's a lot higher. This is also how you'd configure your own printer if you design one. You could say, okay, I want a bed size that's 400 by 400. And then you can change it in here. Minimum software end stops contain movement within the minimum coordinate bounds. So this is a special setting I haven't really played with in a while. But you can see that they've also added some more stuff for the mechanical arm. This originally wasn't, I think, on previous versions, but it might be new. And then we have runout sensors. And it looks like they're talking about pull up and pull down overrides. These smooth out signals in your end stop runout. As for state low, I think that's new, but I'm not sure. It might be low and high. But they talk about filament runout. This actually used to be in the advanced configuration, so they pushed it over to regular configuration. But that was more like 1.8 when they did that. Then you have different types of bed leveling, and as you can see, they're recommending with their config file to use this type. There are other types that I think universal bed leveling, which I'm not sure which one it is right here. It should be UBL. There it is the one below it. That may work. I don't know if they broke it. I try and stay away from talking about the BL Touch only because it's a lot of work to explain and lots of things can happen. The last thing we discovered last week was the wiring. Let me see if I can show you this. I gotta find a BL Touch. I had it here on the desk. Let's see if I can find it. Oh, it might be down on the floor. Okay, here we go. This isn't going to be the BL Touch in this case. It'll be a 3D Touch, unless I've got a BL Touch in here. Oh, that's a Smart 3V. So, essentially, you'll see what I'm talking about. So, let me switch over to the camera for a second. So there's a type of sensor that is sensitive to the surface, and it uses a Hall effect sensor to increase its sensitivity down in here. And then it's got 5 wires coming off. The issue with the wires is this. On this particular design, they have a connector that goes in, and then they have two broken out ones, and then they have extender cables. One of the issues with the extender cables is that they don't make a very good connection sometimes. So if you splice them together according to your configuration, you may be able to resolve that issue. Now this is an extender at the moment on this part only for the actual servo portion. So it would be, I think, this one. Don't know how this fits in. That's awesome. Okay, it's a ridge connection. So it's probably going to fit in like so, if I can get it in the hole. Or like so. But I don't know what they're doing with their design here, because I can see the ridges here. And I can see the ridges in here. So in theory, it should go like this. There it goes. And then lock in. What you're probably going to need to do if it doesn't work when you're running it with the servo is splice this wire to this wire to this wire to this. Now in this case, if I remember correctly, the yellow wire is signal, the red wire is probably voltage, and then ground, but check your documentation because this can vary. But essentially I've done a million tutorials on what to hook up. You may have to reverse them around depending upon what you're connecting to for your servo. So also check your board pinouts, because certain boards like the SKR version 3 and version 4, they reverse two pins being voltage and ground, which probably caused a lot of people aggravation. So that is why you go to your pinout diagram and check it, and I'll show you what I mean. If we go over here, we minimize this for a second, and we find, let's find this example. This will make hopefully some clarity for what's going on. So if we go over here and we look at the pinout diagram, which would be under hardware, we're going to look for servo. I don't know if they're going to label it. I think it's over in here. So there's servo pins down here. It's 5 volts, ground, and then it's your signal pin. Now if we copy this and we go back over to this folder and go to the version 4, and then we go to hardware, and then we go to pinouts. Hopefully it'll be different. They may have fixed it. So we got to find the actual servo, which is right here. So the servo, I got to trace it down to where they put it. And apparently I'm not seeing it where I want to see it. So probe, there we go. So it says ground power voltage. So if we go over to this one, it was voltage, ground, and then the actual signal pin. So ground was in the center, whereas over here it's on the left hand side. So you have to move your pins around. So this is why I always check this before I damage my board, which I've done many times, just because they change things around. So it's kind of a habit now that I check to see what it is before I plug it in and power it. So I know that's kind of silly, but I thought I'd show you that. It kind of makes sense after you've cooked a board or two, or at least in my case. So now that we talked about the actual sensor and the ways to hook it up, in the comparison file, which hopefully I'm on, there we go, you can see that you've got multiple options. You can only pick one of these 5. Some of these may not work because I've tried them. But now you know about bed leveling. Now they have grid points, so this will tell you that it's doing more grid points for bed leveling. And then I'll show you other things about your configuration. Now they may not match up because of the age between the actual designs. So certain things might not be labeled correctly in your example files. That's just something to keep in mind. That's why you're going to do a file compare and find what you're looking for. Then they have the ability to turn on bed leveling. This will be on your display. Now the auto bed leveling in this case is going to be on your LCD display. So if you're using the display for Big Tree Tech, which I'll show you right now, there's going to be two modes to this display. So you're going to have to hold this down and change to the Marlin mode or to the touchscreen mode. It's the Marlin mode that they're talking about. So let's go back over here. So essentially this is Marlin mode, I believe. Now there's going to be other settings that they'll probably highlight in here, such as Z-Safe homing. This is so it takes it to the center of your print bed rather than homing down the side, because on some boards there is no side when it goes to home because you've disconnected it to hook up the BL Touch. So it'll keep going down until it breaks apart your Z axis. Then of course they have feed rate changes down in here, which don't look terribly different between these two. But up here obviously they're not using it in the default file. Then they're talking about offsets, EEPROM settings, of course. This is rewritable storage or persistent storage. And they give you the commands to actually work with it and tell you what to do. So these are the G codes. Then down here we've got the preheat temperatures that they're giving you. You can see there's a difference between these. You can actually go with 180 for PLA. The reason I used to do 180 for PLA was that was the minimum melt temperature, so I didn't have to use a heat bed, and I could print and it would cool off before it would shrink too much. But now I just run at 200 like everyone else and use a heat bed. But if you don't have a heat bed, at least you know a workaround. So this has to do with parking the nozzle, obviously. And parking the nozzle may be part of the changing filament. Can't remember. But they talk about different things for nozzle cleaning features. This is where the nozzle will go off into a corner, spray out some filament. Because if you're changing colors, sometimes you want to do that. So one of the ways you do that is by nozzle cleaning, by pushing a different filament through. Now there's multiple ways to change filament. You can either change it with an automatic like switch that works to path different filament in. But the upside to that is it might switch paths or it may not. It may jam. So I usually just have separate inputs, usually two of two different colors, and just keep printing with pressure. But that's when you can do the purge up here of your print head. Then of course they talk about some G codes in here and what they do. You can set print counter. I don't use it, but I'm sure other people like to use it. It's a good way if you make something for somebody else and you want to know how many prints they've done. It'll be written into the EEPROM so you can check it. That way you can tell what the life cycle of the actual printer is. Then of course they're starting to talk about displays and languages. Obviously there's 3 different types of language writing that they talk about, but there's probably more you could add if you feel like it. And then of course there's going to be multiple languages that you can do this in. I can't remember where they are, but this is how you enable the speaker. You can set this up to individually home accesses. There's a lot of functionality in the regular RepRap Discount Full Graphics Smart Controller that they're allowing you to access right here. Then if you scroll down further, they talk about different types of displays that you can use. This is more one of the common ones. There's a second one that has a similar name. Those are the two that are most often used. And then you go into different types of manufacturers from here. And they're using basically the pins files to align these with your particular configuration. So if you don't see it specified in your pins file and it crashes when you compile, it's probably because it's not specified as something that can be used in your pins file. So then they talk about more displays, and I think you can add generic ones now. There's I2C displays. This is, I think, 4 wires. So it's clock, ground, voltage, and then TX and RX. I can't remember what all the wires are. There might be 4 or 5. And then UART, I think, is slimmer. I can't remember if they have displays for that, but similar concept. It's just the way they're moving information across from the printer board to your display panel or LCD. So as you can see, there's a lot of displays stuck in here. Some of them are the FISEC ones. I've been experimenting with these. I'm not impressed at all. And the reason being is I've done some spider tutorials, but the displays, I order them, I hook them up once and they break. So I'm trying to avoid these displays or even doing a tutorial about them. But essentially it's just removing the comment. But my personal opinion, don't buy these because you're just wasting money. Let's see. They talk about a particular printer here. This is the stock display that comes with your Creality. So if you're using this display and you don't want to change to a newer one, that's how you do it. So they have it defaulted uncommented for your convenience. Then of course they have different displays even again, and I'm sure this is going to go on for a while. So they're talking about other displays down in here, and it's probably going to go on for another page. Now they're getting into the MKS displays. This, I mean, the MKS displays, most of them I'm not impressed. I've worked with them before, but they're hard to configure. Essentially, you do the 2 EXPs and then you configure it, but they also have a special connector in some cases, whereas obviously SKR or Big Tree Tech has a defined TFT cable or parallel EXP cable, ribbon cable connections. So that's why I prefer it. But you can use both, it's just a little bit more work. And they're not going to talk about it in this file because it's an example file for the Big Tree Tech stuff. But you could probably pick out the config file for a maker-based product and do the exact same process. So I guess there's extra features. You can set the number of fans. This might be on the display, I can't remember. I have to scan through here because I haven't gone through this in a while. They have different types of hardware. Barracuda is an extruder. It's for paste. This, I did a tutorial years ago on how to make one. I think it's still up on Thingiverse. Then they have the Blink M, which you can order from Robo something or other. And then they have different types of LEDs and drivers that you can use. There may be circuitry that you need to add in between for at least the bottom 3 right here. This one I'm pretty sure is I2C, so it's easy to do. Whereas the other ones I'm not sure of because I haven't been able to obtain them. But you can see that you can set a whole bunch of functionality with them right in here. Some of it automatic. Then you have your servos, which means we're at the end of the file almost. And essentially in here for servos, they have it defaulted to 3. This goes back to when it was the old ramps board and there were 4 of them. But technically they made a mistake where the speed right here is 300 milliseconds. So if you uncomment this right here and you have 3 and then you want to use this, you have to do this. They may have fixed it, but that caused me a lot of confusion because it wasn't obvious. So that's for 3. If you were to do 4, you would just add another one, and this is just a delay, I believe. But apparently it's required, or it was required unless they fixed it. And then of course they're talking about servo angles, I guess, and what they would be in EEPROM down here. So essentially the file is pretty simple. Let me check to see if there's any questions, because I know I've been talking an awful long time. Well, apparently no questions. So we can do the same thing with the advanced. I'm not going to save the changes. I'm just going to discard. But if we go back over here and we want to figure out what the advanced configuration is, we're going to click here, hold the control button, click the other one we downloaded, right click, then we'll go over to SVN again and do diff. And as you can see, there's obviously a date issue. I don't know why the example configuration is ahead of the actual Marlin configuration, but okay. Someone can write a bug on that if they want, and I'll show you how to do that. If you go over to Marlin's website and essentially go to the bug tracking issues, you can create a new issue, and then you can create the bug, show them the example of what the differences are, and also let them know what the year is. They might give you a funny answer. They like to give me funny answers, but essentially that's a good way to troubleshoot for them to tell them about an issue. So if we were to go back over to here, you can see that they named the file again. And then there's not going to be a lot of differences until we get to the stepper drivers. Now, some of these steppers we may have just passed already, but these are thermal settings, and this is something different and new, which hopefully is arriving any minute. But I'm trying to figure out this situation. The hardware may come today, but I've got to solder it together. So I don't want to embarrass myself by soldering on a new soldering iron in front of you guys. But as you can see, there's a lot of new functionality that they've added in here. Generally, when they're developing stuff, they put it in the advanced configuration. Or if it's an advanced subject, they put it in here. So there's different things you can configure having to do with chambers. I guess there's a laser cooling option, which is kind of cool. Unfortunately, I'm probably not going to cover laser cooling just because of safety concerns. One of the things people don't understand is when a laser makes contact with certain types of elements, such as maybe aluminum, I think you free hydrogen and thus it becomes explosive. That's why I don't cover it. Not that I've blown anything up, it's just I don't want to show you how to do it. But essentially, this talks about the subject of laser cooling, which I might have to research some because this seems interesting, but not sure I'm going to do a tutorial on it. Down in here, they're talking about more about something, but it seems to be about thermistors. So this has to do with possibly cooling and the loops that you see where it heats and cools. Not sure, I've never used it. I try and stay away from it because it can become dangerous. They talk about some of the formulas involved with that stuff, I'm guessing. They talk about, I guess, automatic temperature mode. Then you have run out extruders. You can then specify what to do for the temperatures when it runs out, timing. I think there was movement up in here for it, but it's been forever since I've used it. But this is the run out sensor. Let me double check on my configuration here. Then cooling fans, you can do special types of cooling fans. They've got about 2 to 3 different types of ways to do cooling, if not more. PWM means pulse width modulation. It's essentially, I think, digital is what they're trying to say, but it's squares go up, squares go down. It's a way of modifying how the fan goes on and what speed it runs at. They talk more about it. Then they allow you to choose pins. As you can see in this case, they chose a pin for advanced cooling. And then this functionality I think might be new, or at least for me it's new. More fan stuff. I've never used a fan mux. I would like to, but I haven't been able to find the configuration that works yet. Talking about case lightings, all the functionality that makes it kind of makes your printer unique. You can do dual stepping. I've talked about this before. So basically two steppers. Usually they function in opposite directions, but you can do that for several different types of axes. If you do this, remember certain boards have 2 ports that you can plug in for 1 stepper. It's easier to do. If you do 2 on 1 board, being 2 steppers, things can become complex quick. Let's see, dual carriages, that means that you can do 2 different carriages on the x-axis for printing. It's highly complex in that you have to match up the point at which they overlap. So if you do something like this, keep in mind that your prints might have shifting in them until you calibrate correctly. They talk about it some more. Let's see. Define sensorless backoff. So essentially, when it homes, it'll move 2 millimeters away, I believe is what that means. I haven't used this in ages. I just go with the defaults. So there's a 0, and then up here I think it's going to be 2 millimeters it backs off. So it's going to tap, then it might come back for a second tap, and then it'll move off 2 millimeters. That's usually how it works now. So if your sensor doesn't work when you click the end stop, like I show in the video for testing them, it's probably a double click. Then they talk about more configuration for the BL Touch inside here and more functionality that you can set. Some of the newer BL Touches, they've changed the power and how it runs. So you can see that they've changed the setting right here. The older ones, you didn't have to worry about any of these configurations. But there's a lot more configuration that's been added. Let's see. I guess this has to do with the lining steppers. I've never worked with it, but that seems interesting. Tramming, that's bed leveling, I believe. So it's saying where you're going to touch the sensor. Back to inverting pins. So you're reversing what the actual processor reads to something the opposite of what it is. That's all they're talking about. And obviously this looks like it's for the ARM based on the IJKE. It also might be a different way to do printers in the future. Obviously, it's a timeout. Not exactly sure what that functionality is for, but it looks like something for a buffer. A buffer is like a, say you go into a line at the supermarket and you're standing behind other people. That's like a queue. So that might be the buffer, or they might be referring to a time delay. Let's see, XY frequency limiting. Not exactly sure what this functionality is for, but they explain up above what it probably is for. Backlash, that has to compensate for the actual movement of axes. Usually it's the Z axis, but if you get really good hardware, you can put a spring in between on your Z axis, and that usually compensates for it. The other thing I do that most people don't know is I print on a rubberized workout cushion that absorbs some of the force of the printer and helps it print more comfortably, we'll say. It's kind of like earthquake proofing your printer to a degree. Not that it earthquake proofs your printer, but the shake it puts off, it reduces. That's why on the Creality they have rubber stickers on the bottom. That's another way they're doing it. So I guess you can calibrate the feed rate from fast and slow. These are advanced configuration things. I've never actually used them. I don't even know if they're useful, but I'm sure people can notice if they get really in deep trying to mess with these. But usually I start from default and I adjust everything in Cura or Slicer, which are slicer programs that create the G-code files for the printer. I guess there's custom microstepping, and I guess it says what it's doing. So I don't really talk about this too much. Essentially, some people like it, some people don't. But you may run into a doubling situation like I've talked about with steppers before. Digpot, I think that has to do with an adjustment on the actual stepper, like DRB 8825s and A4988s. But I don't know for sure because I've never used it. But it's a digital potentiometer, I think is what they're trying to say. It's kind of like a volume switch that you would use on, I don't know, your radio player for volume. This looks like something they're talking about, certain memory locations that they're trying to talk to, and I think they're shifting bits, but I'm not sure it's in hex. So 58 versus 2C in hexes counts from 0 to F. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F would be hex. Binary would be 0 and 1. I guess there's additional features for LCDs in here. Talking about, I guess, beeping and frequencies and all sorts of little things. But you can see there's more LCD menus for this configuration where they've added something. But you're allowed a lot of flexibility in what you can set up. Let's see, menu sound item. I guess you can set a sound when you select something. I've actually never used this, but it's kind of cool. This was an old functionality. I think it changed directions, or it would show you status messages. Maybe this is new, but there was a way to modify your actual SD and I think they moved some of that into here. SD support, that's your SD card in a SPI situation, I guess. Being serial peripheral interface. It's talking about how to work with different types of media, essentially. Power loss recovery. This would be like the free signal pins on your end stops. If you lose power, you might be able to save the current state of the printer and then power it back up. Personally, I don't believe in it, only because if you lose the power, your extruder will be sitting over something it was printing and melting that away while it's cooling off. So power loss recovery, in my opinion, is useless because you've already destroyed your model because your extruder is sitting there cooking it. But other people have a different take on that, and I get it. Let's see, I'm trying to find something of interest, but it's talking about a lot of SD card functionality. UTF is, I think, a standard for how text is displayed or its bed leveling. Oh, uniform something files. So this is the file name support. So I think it's long file names or something. There's some kind of pattern that it deals with. I can't remember exactly what UTF means. It's universal text formatting, maybe? But we can always Google it. This is talking about, I think, either UART or SPI. I'm just trying to figure out which. But you can see there's a synchronized clock. Then there's master out, slave in, master in, slave out. These are names of pins. And I forgot what these are, but it looks like it's something to do with an SD card in this case. But these are just abbreviations I know from something else. Probably has to do with this display or a card reader. USB flash drive support. Most boards have it default for 32-bit. Some do not, and you have to use the display to do it. I want to get away from this stuff because it's basically talking about the SD card ad infinitum. I want to actually get down to something more interesting. Let's see. It looks like you can customize your screen. A lot of this functionality I haven't seen before, so it's taken me a second to register. But it's all about customizing your LCD screen, I guess. Depending upon your configuration, maybe. And now they're talking about touchscreens, so there might be more of the same. Universal text format, 8 Western characters. Well, there might be some security features. Here's an interesting one. It's use Watchdog. Watchdog is a way to restart programs if something happens. Usually they don't restart, and that's a good thing. So I leave it alone, but if you want to use it, it might be helpful in restarting from a situation. I don't recommend it because if you're in a bad situation, you want to know it. That way you can correct it. They're talking about baby stepping some more. This is probably something on the display. So let me see if I can find something about steppers. Okay, this has to do with printing. Okay, they're talking about stepper drivers here. I'm not exactly sure what the functionality is that they're talking about, but it might be something to do with direct stepping, or it might be something else. I'm not sure. but they're explaining what menu options you have for choices down someplace. I'm not exactly sure, never used it before. Buffers is memory. There's a lot of new functionality that I've not used. This is probably firmware retraction. So they tell you what the G codes are. It's probably going to be saved in EEPROM, which is rewritable memory. Tool changes. So sometimes you can use a magnet and swap tools. Hopefully you got a good magnet or servo to lock things in place, but essentially you can change your tool like drill bits and stuff like that. But CNC I've not done in Marlin. I think there might be other firmware for it. Switching tool heads, dual carriages, or parking an extruder. Then it's talking about feed rate, purge. It feels like I'm going in circles, but I think we just got to extruders, or excuse me, steppers. So this is a TMC 26X. Obviously there's a different setting for these. You're gonna have to research what these are because they will vary. This is a higher amp stepper, whereas the ones we use are lower, or the ones I talk about, and they're down in here. So you can see that in this case they cranked the current down to 580. I usually start at 750, but that may be their preference. And then of course they're probably going to talk about sensorless homing in a second. Also, they may screw up these currents depending upon what they're working with, but the default is 11. So if someone tells you otherwise, it's probably they're working with a 5160 or a 5130, I think. Then it would be 0.075, I think. But those are usually the two that you have to worry about. And obviously I cover what's going on with the, where is it? Here we go, microsteps. I talk about that usually in the stepper tutorials, so I'm not going to cover that right now. And they keep going. Then they have specialized chipset select pins. Depending upon your stepper, you might have a different chip select that you're using. So you may have to use that instead. If you're wiring manually, sometimes this occurs. Now they've added this, I think. I'm not exactly sure what this is, but it has to do with the TMC 2209. 4 TMC 2209 drivers can use the same hardware-software serial port with hardware configured addresses. And then they talk about that. I've never used it at the moment. It may become relevant soon. Then of course there's some stuff you can do with master slave on steppers. I wouldn't suggest talking about this because it's going to waste our time. There's different types of stealth chop. This is quiet printing or accelerated, I forgot which. But essentially you can speed up your printer. It will start to make a lot more noise if you use stealth chop or not. I can't remember which it is. It says stealth chop. It might be that I'm thinking of something else, but you have to adjust your power supply to it, or at least it's a suggested good idea. Trying to find the different setting here. Monitor driver status is on by default. You can turn this off after you've set up your steppers, as long as you know they work. Hybrid threshold. This is where you can speed up the printer. So essentially, you can run the printer at a faster speed, but the noise level will increase depending upon your speed. I have shown videos where I've sped up the printer. It wasn't the videos sped up, it was me screwing around with speeds on the printer. I didn't use hybrid threshold though. I was actually using stealth chop. Then of course they talk about configuring sensitivity for stall guard, which is sensorless homing, and they enable it I think by default here. 70 is usually not a good value, and the reason they're doing this is because up above they changed the current. So essentially they're putting 70 in as the value. Usually it's 125 and it's around 750 or 800 way up here. But they've done something that they think that's dialed in the right actual sensitivity. That may be the case, but ever since I've been doing these, it's always been 125 and I'm about 750 to 800 for that value. But they may know something I don't, because I'm not an electrical engineer. Or at least my degree is not in electrical engineering. Square wave stepping, that's a square wave, which would be like digital. Or I hope so. Let's see, debug codes. So essentially all of this down here is talking about different types of steppers and what you can do with them. I don't know how much further this goes, but someone wanted me to talk about, you know, the functionality of the actual Marlin firmware. Oh, they're talking about lasers in here. That's interesting. So I'm gonna have to do some research on this. I probably won't do a tutorial on it, but I'm at least interested in what they're talking about. I don't recommend doing it if you're a beginner. Learn your stuff before doing this and get all the protective equipment that you should use for that, and then use it even if you don't think you're using the laser. Use it anyways until the whole system's powered down. It's just to protect your eyes, and also ventilation with lasers is the number 2 important thing. This is some kind of experimental thing that I don't know how to use. Disable drivers, safe power protect. This might be something new that they're adding. Auto report temperatures, I think it already does. So it's enabled in both. This is usually hidden functionality. If we're in Pronterface, inside here, if you were connected to a board, you could see hidden functionality by going to debug communications, and over in here it would print out what's going on. It's usually disabled by default. Also, people talk about different extruders. Sometimes they don't see the other extruder. That's also a setting in here where you go to options. When you bring up options, you can increase your extruder count here. You have to save it or close and then reopen, and then that functionality will appear as a tool choice when you're connected. Otherwise it'll disappear. So if I go over to options and I change this back, and then I have to close and reopen, I think that'll be gone. And it is. So that's some weird functionality in Pronterface. But let me go back over to the comparison for a second. Not sure what this is, but it has to do with volume. It might be something they're referring to in calculus when moving the printer. I'd have to look this up because I don't know what this means. Obviously I know what volume means. It's the container inside, or the equation of the container inside being the second or third derivative. I think it's second derivative. Sorry, it's been 30 years since I've studied calculus. But all this functionality I'm not super familiar with, as you can tell. but there seems to be some interesting stuff in here that I have to actually research. And this looks like menus that you can set inside a display, or it might be something else. This is now usually packed in the display for the software. I don't know if that's the case here or if it's something you can preload to an LCD. It says LCD dependent, so I'm guessing that's the case. So it's making it similar to the TFT displays of Big Tree Tech. And they're basically giving you examples on how to set it up, and then you just fill in the blanks. This I'm not sure of, but it looks like it's something that you can put on the display. Maybe a button that you can scroll to, I'm not sure. But this is some interesting new functionality. They also include wikis for certain things that they talk about and certain people that might be an expert in them. Now they're talking about I2C. But essentially I'm just showing you a bunch of things. Joystick, I think this might be something you can hook up to ramps. There was something I was going to do it for a tutorial years ago on a joystick configuration. I think I actually have the board. One of these days I'll try it. But a lot of this functionality I'm not super familiar with. But you can tell that by how I'm talking about it. Debugging pin. This is a good one. If you use a certain G code, you can turn your actual pin on, and you can actually measure if it's 5 volts or 3.5 or 3.3 volts to see if it's functioning correctly, and then move it to 0. This I've used before. The only problem is when they have protected pins, you won't be able to see it, but they give you the G codes right here for the two different things. There's a way to turn it to high, I just don't remember. But it says the display pin status, and then M42 is set pin state, so it's either high or low. And that corresponds to, if you go over to here, and we go over to the Marlin website, and we go to, I think it's help G codes. If it ever gets there, let's go all documents. If you look down through here, you can find the command. It's obviously not that one, so it's the M version, which I may have just scrolled by. Right here, pin state. It gives you the example files on how to do it down below, so you can test out certain functionality. So I hope that answered a lot of questions. I know I've been talking continuously now for probably an hour and a half, and I don't know how many people fell asleep. Hello, Jessica. Hi, Marcelo. Hey, Russian guy that I can't read your handwriting, even though you're trying to advertise something. Don't click on the extension. Apparently there's multiple Russian guys in here doing that. Well, at least they got their scripting down. But if you guys have questions, obviously I've been talking for an awful long time, and you can tell I'm somewhat tired. I'll show you where you can post YouTube requests. Let me just get the screen over there. So on Discord, there is a bunch of different chat rooms. Most common used one is general chat. This is where people talk about issues and try and get other people to explain what their knowledge is, and vice versa. We have a chat room for BTT TFT displays where a lot of conversations occur. There's print quality, where people are trying to get the quality of their prints to improve. And it looks like this person just really moved up in quality. Apparently he's printing the lamp from whatever that story is about the kid and the BB gun. Then we have BL Touch. Some of this material gone over before in old videos, so they might be talking about stuff that's from 1.1 that I've done. Then we have Share Your Designs. If you want to share what you're working on, other people share their designs to show you what they're thinking about doing. Then of course we've got the Clipper. This is a different type of firmware. This is more for an advanced user. I've done a couple of videos on it. There's more complexity I haven't covered yet, but Clipper is something that some people enjoy a great deal because it controls printing better. And then up here we have YouTube requests. You can put a request in here as to what you want to see. I don't usually check this every day. I check it like once a week. So some of the stuff I have purchased, depending upon the price. Some of it's very expensive and I haven't. And I'll usually let somebody know that I can't do that due to the cost. That covers most of the rooms that you guys can see. Obviously you can see there are other rooms. Try not to comment in here if possible. Granted, I've gotten a little crazy with strawberry shortcake in there, which you probably shouldn't have. But that's a good place to communicate with me or other people in the chat regarding 3D printing. Also, for the people that are leaving, tips in either PayPal or signing up for Patreon, I can't see those in chat, but if you've been doing it, thank you very much. It's much appreciated and helps offset the cost of doing this. But I'm gonna wrap this up. I'll probably be in chat in a couple minutes, so if you got any questions, let me know, or other people might be able to answer them. And I'll catch up with you guys later on this week. Hopefully next week we can do this at the same time, depending upon my work schedule. And hopefully I'll be able to start posting videos again as soon as things calm down at work. So everyone, thank you very much. Take care, be safe, wear a mask, get vaccinated if you can. And I'll catch up with you next time.